So I am Ashutosh Khandal and currently pursuing my BTech at IIT Delhi in mechanical branch. And today I'm going to discuss on the topic machine learning model for estimating ship noise in Indian Ocean region. Like first of all, we have to look at the background of ship noise and why we have to estimate the ship noise and what is the issue. What is the major issue because of that we are trying to estimate the ship noise. So like ship noise is a major issue from different perspective, like for human health, like for the hearing disability for crew members present on ship, and severely bad impact on marine mammals, and also the major requirement for naval platforms for achieving higher acoustic stealth and all. And so because of that, and because of that, we have to manage. We have to do management of underwater radiated noise, and for, for that we have to first, we have to look what are the sources for ship noise. For management of ship noise, first we have to understand the sources of ship noise. So for that, like the objectives here, there are these are two main objectives of my study. The one objective is that whether there is a need of machine learning model for estimating shipping noise or not, and how it is better than existing mathematical models. And the second objective is to develop a machine learning model based on to develop a machine learning model for estimating ship noise in Indian Ocean region, and also developing in GUI so that any user can run my trend model by providing their own PIS dataset. So here is my methodology for on this project. So like for the objective of to establish the need, so for that we have to first look at some like previous existing mathematical models and try to find out why we are going towards ML based model. What are the drawbacks of these models? So for that I need some papers, and now the second objective to develop ML based model. So for that we have to look at some ML based algorithms and how this ML based algorithms can be we can apply in the maritime domain, and which algorithm we can use, which algorithm is best. So like we have to try with the different algorithms, and then developing GUI. So for that we have to learn up some GUI toolkits like PyQt5 and Qt Designer and some literature survey. So like there are many papers, different papers from there. I learned like what are the ship noise sources, and how the how the mathematical models estimate the ship noise, and what are the drawbacks, and how actual measurement, how like in this paper measurement of radiated underwater noise from small research vessel. In this paper, like tell about how the actual measurement and how the actual measurement are taken, and how we analyze the measured data and all, and like some papers on the machine learning, how we apply machine learning in the maritime domain. These are. So now in my mind map. So like the objective is ML based model. So for that, first we have to see the issue. What is the issue? Like acoustic stealth and acoustic bit degradation and all. And then we have to see the noise causes like propeller cavitation, machinery noise and all. And then we have to see what are the gaps in the study and why we are going towards ML based. So lack of efficient ML based model, and lack of effective URL management plan, and many problems with AIS data and all. So now comes to estimation approaches. So there are two estimation approaches. First is computational model, like different computational models, computational fluid dynamics, propeller analysis, FE analysis, and second is the empirical one. So like D. Rose, Randy, Volset, Mears, Sonic, and Wittigen. So in these models, Wittigen model is best, is more accurate and the modern one. And now we are going towards ML based approach. So for that we can use like neural network based approach, random forest approach, logistic regression. And also as we know, for ML based approach we need some data. So for that data we can use Wittigen output noise data, because the Wittigen model is very accurate in among the empirical models and all. And other than noise data like ship type, ship speed, and other data we can get from AIS dataset. So like we are going towards ML based approach, but first first we have to determine why we are going towards ML based approach. So for that need of ML based, so for that we have to study about the drawbacks of mathematical models, so that we can identify why we are going ML based approach. After that we have to look at like stakeholders, who are the stakeholders of this objective. So like government, military, port authorities, marine services, like and all. So this is, so like ship noise sources. There are three main sources of ship noise. First is the propeller noise, the most efficient and most dominant source of underwater radiated noise. This is because of, mainly because of cavitation. Because of pressure difference, the cavitation bubble make an and when the cavitation bubbles implode, then low frequency broadband noise generates. And the second is the machinery noise, that is because of mainly engines, propulsion, auxiliary system, gearbox, ducts and pipes and all. And third is the hydrodynamic noise, that is because of interaction of hull and appendages to the water. So now URN estimation models. There are broadly two categories of URN estimation models: computational and empirical. So like here we have to look at why we are not using these computational these mathematical models and going ML based models. So here are some drawbacks. Like computational models are highly accurate as compared to empirical, but these methods require a lot of computation and take time to give result. So because of that, it is impractical for use in monitoring in real time. And the drawbacks of empirical models are like some empirical models like Wittigen models requires a lot of parameter, which requires web scraping, and that takes a lot of time and become a cause of slow execution. And also like Wolf's-Hettier model gives inaccurate results at low frequency, and different drawbacks of other models. So because of these drawbacks, we need a machine learning model. So like come to machine learning. So machine learning can be defined level of algorithms which may allow software application to create more accurate forecasting output. So ML is starting to rise in shipping industry, and lot of research has done previously on the ML, like classification of underwater acoustic targets, enhance the maintenance process, anomaly detection in maritime domain and all. So here in this study, I chose the artificial neural network approach to predict the Wittig's output noise by taking less parameters, which are easily available. And I choose the neural network approach because like currently neural network approach is widely used in many areas, and it's a good and accurate approach. So input parameters for training my artificial neural network are like frequency, ship speed, ship length, ship deadweight, ship type. These are. So now come to the results. So like I tested my trained neural network model for 2105 test data, and I got the 3.02 mean square loss in the predicting data. So here this is the my result. So like I tested for 2105 data, and from that I got almost 1400 data. For that I got the less than 1 decibel difference in predicting and expecting in an actual noise, and also like 600, so total 2000 data where I got the less than 3 decibel difference from the actual and predicting. So that's a good that's a good accuracy of my model. And now come to the GUI development, the my last task of my project. So I use the Qt Designer and PyQt5 GUI toolkit for developing GUI so that any user can run my trained model. So this is how my GUI graphical user interface looks like, where we can put the input and pressing submit button will give the output noise value. So like now way forward, the further research direction, like many areas where the further work is required, including this noise models, problem with AI data and all. So like first, I identify like the lack of open database. Is the data availability is one challenge for URN management study. We have to focus on the built up an open database, because like if we have good amount of data and correct data, so that we can train our the training of our model will be more accurate, so that we should keep an open database for study. And second is the many limitation of AIS data that can be fixed with the AI or ML, with the help of AI and ML. And also hardware and software, like ML based model is to be run on the ships, so we have to do we have to do these models these artificial neural networks or other algorithms on the hardware present on the ships, so that if such technology is present on ship, then it may be leveraged. So these are some differences, and that's all. Thank you all of you.